Hello everyone. Today let us discuss about applications of dimensional analysis. In our last video, we have studied about dimensional formulae, dimensional equations, and how to apply those dimensional equations to various physical quantities. All that we have learnt in our previous video. Now, we have come to a most important topic, that is applications of dimensional analysis. Applications of dimensional analysis. Let us see what we can do with this dimensional analysis. So, now the method of studying a physical phenomenon on the basis of dimensions is called dimensional analysis. So, if we are studying a physical phenomena on the basis of this dimensional formula, then we call it as dimensional analysis. With this dimensional analysis, what can we do? There are mainly three applications of dimensional analysis. Mainly, we have three applications. So let us see one by one and learn very carefully because it is very important topic. So, the first application to check the dimensional consistency of equations. This is the first application to check the dimensional consistency of equations. What is the meaning? The meaning is to check the correctness of a given physical relation. Correctness of physical relation means we have to see whether left hand side is equal to right hand side of the equation. This is also called as the principle of homogeneity of dimensions. This is also called as the principle of homogeneity of dimensions. Clearly, every topic one by one we will see now in this today's video. Next, second application to deduce certain relations among different physical quantities and checking the derivation. What is the second application? To deduce certain relations among different physical quantities and checking the derivation. Means they will give some physical quantities and we have to derive the particular equation and see whether that equation is right or wrong. I will explain this in detail today after finishing this third point. Everything, all the points I will explain now. Now, third application to convert a physical quantity from one system of units to another. We have different systems of units. Yes or no? Have we learnt? We have learnt MKS system, FPS system, CGS system, and they may give some other system also. They sometimes in the examination they give a new kind of system they give. So how to convert from one system to another system? That is the third application. Even though it takes time, it's worth to watch this video because this particular topic will have maximum marks in the board paper because you have to answer long answer questions based on these three applications. Let us discuss these applications one by one. Okay. Now, the first application. So the first application is to check the dimensional consistency of equations. The first application is to check the dimensional consistency of equations. What is checking the dimensional consistency? Dimensional consistency means to check whether the equation is right or wrong. So according to this principle, a physical equation will be dimensionally correct if the dimensions of all the terms on both sides of the equation are same. What does it mean? It means if you take any dimensional equations, any dimensional equation if you take, first find out the dimensions in the LHS, that is left hand side of the equation, and then find the dimensional equations, dimensional formula for the right hand quantities, all left hand side quantities and all right hand side quantities. You have to find the dimensional formula. Then for every term the dimensional formula should be same. It should be same. If the dimensional formula is same for all the quantities, means for all the terms of LHS and RHS, then we say that that the equation is correct. Now let us see. Let us consider Einstein's formula. So we all know Einstein's formula very well. Yes or no? We all know we all know Einstein's formula very well. E is equal to mc square. So where E is the where E is the energy, m is the mass, c is the velocity of light. Where E is the energy, m is the mass, c is the velocity of light. What we have to do now? Take dimensional formula for the energy. So let us take LHS. LHS means energy. We have to put it in a square bracket. That means we are finding dimensional formula. For energy, dimensional formula is m1L2T minus 2. m1L2T minus 2. RHS we have mc square. RHS we have mc square. So now if you see that mc square, mass into velocity square. For mass it is m, velocity lt minus 1, and it has square, therefore whole to the power of 2. That will become m1 L2 T minus 2. Clearly you can see now, very clearly you can see now, here you can see LHS has a dimensional formula m1L2T minus 2. Similarly, RHS also a dimensional formula m1L2T minus 2. Both of them have same dimensional formula m1L2T minus 2. Okay, so then what we have learned here is, here we have learned that dimensional formula for LHS and RHS is same. Therefore this above relationship is correct. This is a correct relationship. Now we will take another another example. Example 2. For the same application, I have taken another example. This is escape velocity. V is equal to under root 2gm by r. Under root 2gm by r. So if you see here, we know that escape velocity means, generally we use in the chapter of satellites, gravitation. There we use v is the escape velocity of the satellite, and under root g. G means universal gravitational constant. M is the mass of that satellite, and then r is the radius. R is the radius uh, of that orbit. Now let us see LHS v, that is velocity. Whatever may be the velocity, the dimensional formula is same. For every velocity, dimensional formula is same. This I have already explained in my previous video. So now if you see for LHS, the dimensional formula is, you can clearly see for LHS, that is, sorry, for LHS, the dimensional formula, you can clearly see it is V is equal to LT minus 1. V is equal to LT minus 1. Okay. So similarly, RHS we will take 2 GM by R under root. Under root, under root means to the power of 1 by 2. To the power of 1 by 2. So we are taking it is under root. So under root means to the power of 1 by 2. So we will take 2. 2 means it is a constant. We don't have dimensional formula for the constants. So we will see for gravitational constant it is dimensional formula is m minus 1 m minus 1 L3 T minus 2, and for mass it is m, and radius, that is length, so divided by length, whole to the power of 1 by 2. So now you can see m to the power of minus 1, m to the power of plus 1 is cancelled, and L3 and this L in the denominator comes up, it will become L2, L to the power of 2, and T to the power of minus 2, T to the power of minus 2, and finally whole to the power of half, that is under root, it becomes LT minus 1. So if you see for the LHS, the dimensional formula is LT minus 1. Again, for the RHS also, the dimensional formula is LT minus 1. Therefore, what is the conclusion here? This equation is dimensionally consistent. We can conclude that this equation is dimensionally consistent. This equation is dimensionally consistent. Now let's go for another example. It's good to see as many examples as possible because it's good for us only to learn better. Now if you see, we have taken one equation here, that is v square minus u square is equal to 2as. V square minus u square is equal to 2as. Now let's come to LHS. LHS, v square minus u square. V means final velocity, u means initial velocity. For all types of velocity, the dimensional formula is LT minus 1, LT minus 1 whole square and LT minus 1 whole square. Therefore, v square has a dimensional formula L square t to the power of minus 2. L square t to the power of minus 2. For one term, the first term, you got the dimensional formula L square t to the power of minus 2. Similarly, for the second term, u square also, the same thing we will get L square t to the power of minus 2. Let's take the RHS, that is 2as. 2 is a constant which does not have dimensional formula, and a is acceleration LT minus 2, and s is distance which is L. Therefore you will get L square and t minus 2. Now if you see RHS also, we got the same dimensional formula. LHS, LHS we have two terms, v square u square. So v square has L2 t minus 2, u square also has L2 t minus 2. RHS, that is 2as also has L2 t minus 2. Therefore, conclusion, this above equation is correct. We can conclude that the above equation is correct. So like that you can take many examples. So we can take so many examples like this. Another example I have taken, is time period of a simple pendulum, which is t is equal to 2 pi under root L by G. L by G. T is the time period of the simple pendulum, L is the length of the simple pendulum, G is acceleration due to gravity. LHS, time period, simple t, therefore t to the power of 1. RHS under root L by G. L means length, G means acceleration due to gravity, therefore LT minus 2. LT minus 2 whole to the power of 1 by 2 because it is under root. Therefore, L and L cancel. The t minus 2 comes up to the numerator, it becomes t square whole to the power of half, then half 2 and 2 cancel, it becomes t. Now if you observe carefully, you can see that LHS has a dimensional formula single t, that is t to the power of 1. Similarly, RHS also has the same dimensional formula t to the power of 1. Now you can conclude that dimensions of LHS is equal to dimensions of RHS, hence the equation is dimensionally correct. So this is the first application. I hope you all understood, and we have to continue our discussion with other two. We have to continue with other two um, applications. So let's go for the next application. So the next application is deducing relation among the physical quantities. Deducing relation among the physical quantities. As I told you earlier, they will give some physical quantities and we have to find the relationship between them. So what they will do here in the examination, they will give a long answer type question. They will give some quantities and they will ask you to find the relationship between the quantities. It's very, very, very important question. So most of the time you may get it for 5 marks along with a numerical with that. So to derive the relationship among physical quantities, we can make use of dimensional formula. Here also, to reduce relationship between physical quantities, what we are using is dimensional formula. By using the principle of homogeneity of dimensions, we can derive an expression for a physical quantity if we know all the quantities on which it depends. So what does it mean? If we are using the principle of homogeneity, so what we are doing, we are doing we are using the principle of homogeneity of dimensions. We are using the principle of homogeneity of dimensions. Using that, if we know on which the physical quantity depends, if you know on which the physical quantity depends, we can find the relationship between them. It is nothing but like a derivation. So let us take some examples and then we will discuss that. So once we take some examples, then only we can understand better. So let's take one example. Let us derive the expression for the time period of a simple pendulum. The same example I have used earlier for the first application, the same formula. Now we are deriving. That is different, this is different. That we have used, there we have used the same formula for the consistency to check whether the equation is right or wrong. Here we are deriving the expression for the time period of a simple pendulum. Let capital T be the time period of simple pendulum. It depends upon number one, mass of the bob, number two, length of the pendulum, and number three, acceleration due to gravity. So, on which factors it depends? It depends upon the time period, depends upon three things. Clearly, you can see. First one, a time period is directly proportional, or it depends. We cannot say directly proportional, it depends on mass, time period depends upon length, and time period depends upon acceleration due to gravity. So time period depends on mass, time period depends on length, time period depends on acceleration due to gravity. But how it depends, we don't know. So randomly, we have taken mass to the power of A and length to the power of B. Length means length of the pendulum, and G, acceleration due to gravity, that is to the power of C. So time period depends upon mass, length, and acceleration due to gravity. So we are taking m to the power of A, L to the power of B, G to the power of C. We don't know the values of A, B, and C. We don't know the values of A, B, and C. So what we will do now, we have to find the values of A, B, C. Then only we can derive the expression, that is time period of a simple pendulum. Now, what we will do, t is equal to some constant where it is dimensionless quantity, m to the power of a, l to the power of b, g to the power of c. Now, dimensions of the quantities let us take. We will take the dimensions of the quantities. That is t. We all know t. m0, l0, t1. Simple time period. And after that, we know mass to the power of a. So mass to the power of a means we will take this one, that is m to the power of 1, l to the power of 0, t to the power of 0. Next, it depends upon length. Write the dimensions of length. You all know that for the length, mass to the power of 0, length to the power of 1, and time to the power of 0. And the third quantity on which it depends is g, acceleration due to gravity. So for that, you write the dimensions. You all know it, lt to the power of minus 2. lt to the power of minus 2. So first thing is, for the LHS you write dimensional formula. For the RHS also, for each and every quantity you write dimensional formula. RHS, they will only give in the question. On which factors it depends, that will be mentioned in the question. Whatever the factors they have given, depending upon those factors, you write those quantities and write dimensional formulas for them, as I have underlined here. Write a dimensional formula for each and every quantity what they have given in the question. In this particular problem, they have mentioned it depends on the mass of the bob, length of the pendulum, and acceleration due to gravity. So here we have taken a mass, length, and acceleration due to gravity, and we have written the dimensional formula for, we have written the dimensional formula for all of them. So now after that, okay, let us see how we can derive. How we can derive that. So how we can derive? So first look at this equation 1. So please look at this equation 1. You can see here time period is equal to k into m to the power of a, l to the power of b, and g to the power of c. Time period t is equal to constant k into m to the power of a, l to the power of b, g to the power of c. Okay, so now taking that equation, let us substitute the dimensions in equation 1. Let it be equation 1. We will substitute LHS. As you all know, LHS. LHS means only time period. So these are the dimensions. Already we have seen M0, L0, T1. T1. RHS, constant. For constant, we don't have dimensions. Therefore, for the mass, we have already seen m, and for length we have seen it is as l, and for acceleration due to gravity, lt minus 2. So we have written all those dimensional formula, and we have taken the exponents m to the power of a, l to the power of b, lt minus 2 to the power of c. According to the consistency of the equation, that is we have seen in the first example, that is homogeneity of dimensional formulae, LHS is equal to RHS. LHS is equal to RHS. Therefore, LHS means M0, L0, T1. RHS, let us take the powers m to the power of a, L to the power of b here, and L to the power of minus 2c in the last term. L to the power of b in this middle term, L to the power of minus 2c in the last term. So, sorry. Uh, let me tell you once again. Here, mass to the power of a, mass to the power of a, L to the power of b, and in the last term, L to the power of c only, not 2c. I'm sorry, please. In the last term, L to the power of c. So the powers all together for L. In the middle term, the power is b. In the last term, the power is c. Therefore, L to the power of b plus c. L to the power of b plus c. And t to the power of minus 2c. T to the power of minus 2. Outside we have c. So t to the power of minus 2c. Compare the powers on both sides, that is equating the exponents of ml and t on both sides, we get a is equal to 0. LHS m to the power of 0, RHS m to the power of a, therefore a is equal to 0. Now LHS L to the power of 0, RHS L to the power of b plus c, therefore b plus c is equal to 0. Then LHS t to the power of 1 and t to the power of minus 2c. Therefore, minus 2c is equal to 1. Minus 2c is equal to 1. Therefore, from the third equation, minus 2c is equal to 1. Therefore, c is equal to minus 1 by 2. C is equal to minus 1 by 2. Already we came to know a is equal to 0. From the second equation, b plus c is equal to 0, b is equal to minus c, that is minus of minus 2, which is, minus of minus half, which is 1 by 2, which is 1 by 2. Therefore, we got the values a is equal to 0, b is equal to 1 by 2, c is equal to minus 1 by 2. So we got the values now. We got the values here, like what we got: a is equal to 0 and b is equal to 1 by 2 and c is equal to minus 1 by 2. We got the values. Now almost our derivation is over. Substitute these values in the powers formula, that is in equation 1. T is equal to k, m to the power of a means 0, L to the power of b means 1 by 2, g to the power of c means minus 1 by 2. Substitute t is equal to k into L to the power of half by g to the power of half, that is equal to k into under root L by under root g, that is equal to k into under root L by g. From experiments, they found k is equal to 2 pi. Substitute the value. Therefore, t is equal to 2 pi under root L by g. So, finally, what you can write is the derivation is over. We got the derivation t is equal to 2 pi under root L by g. Hence, we have derived the expression for the time period of a simple pendulum. Now here we have derived the expression for the time period of a simple pendulum. So now let's go for another example and see. So I hope you understood this particular one. This is very important one because it is the only one, like main one, which is given in NCRT. Therefore, most of the times in examinations, they repeatedly asked the previous derivation, which is time period of a simple pendulum. Now, to make you to more aware of this particular application, let's go for the another example. That is, frequency nu of a stretched string depends upon, first point, its length L. Second, it depends upon mass per unit length M. Third, it depends on tension T in the string. See, these are given by the people in the examination only. So what you have to do, they have already given frequency nu of a stretched string. What is a stretched string? A stretched string is similar to a string of a guitar, string of a veena, string of a violin, like that. So these are the instruments which we use for uh, playing music, etc. Not only that, many other stretched strings are there. We can learn them later in our last chapter of this 11th standard. We will learn later, but presently we don't want complete details about the stretched string, but we want to derive the expression only. Nu is the frequency. So let us take nu at LHS. Nu is equal to some constant k, which is a dimensionless quantity. L to the power of a, they only gave it depends on length. M to the power of b, b means mass per unit, sorry, m means mass per unit length, and t is the tension in the string. Don't misunderstand, it's not time, it is tension in the string. Tension is nothing but force, so it depends upon the tension in the string. You all know, if the string is tight, then only we can good sound from a guitar. So T stands for tension, it's not time. Please don't get confusion here. So let's take the LHS. Let's take the LHS now. So the LHS is nu. Nu means frequency. Frequency is 1 by time period, that is t to the power of minus 1. T to the power of minus 1. Let's take RHS. RHS, we have three quantities here. RHS, we have three quantities: length, mass per unit length, and a T, that is tension. Length, you all know, M0, L1, T0, then T, that is the tension. Tension is nothing but force. So the dimensional formula for the force is M1 L1 T minus 2. You all know that. Already we have learnt it. Then third one is mass. The mass is nothing but mass per unit length, they said. Therefore, you have to divide mass by length, that is M by L, which is M1 L minus 1 T0. The first quantity is L. So we have taken M0 L1 T0. Second quantity is M. Here we have M means mass per unit length. So we have taken M by L, that is M1 L minus 1 T0. Third quantity is tension. Tension is nothing but force, M1 L1 T minus 2. So substituting them in this first equation, we will get LHS T minus 1, RHS L to the power of A, M L minus 1 to the power of B, M1 L1 T minus 2 to the power of C. LHS M0 L0 T1 and LHS M0 L0 T minus 1, RHS M to the power of, you can see here, M to the power of B, and you can see in the last term M to the power of C. In the middle term M to the power of B, in the last term M to the power of C. So M to the power of B plus C. Now L, in the first term L to the power of A, in the second term L to the power of minus B, in the third term L to the power of C. Therefore L to the power of A, L to the power of A, and then B, and then we have the last term C. C we have. So now if you take them and substitute all these values, and then come to the next one, the last one, that is this one, tension M1 L1 T minus 2, M1 L1 T minus 2 to the power of C. So let us take the time now. First two terms we don't have time, and the last term we have minus 2C. So T to the power of minus 2C. So therefore let us take, and then uh, equate them with the dimensions ml and t. ml and t. There is no mass in the LHS, therefore b plus c is equal to 0. b plus c is equal to 0, and there is no length in the LHS, therefore a minus b plus c is equal to 0, and there is t minus 1 in LHS, t minus 2c in RHS, minus 2c is equal to minus 1, therefore c is equal to 1 by 2. c is equal to 1 by 2. Then b is equal to minus c from this equation, therefore b is equal to 1 minus 1 by 2. Then after that, is equal to, from the second equation, a is equal to b minus c. From this second equation, a is equal to b minus c, that is b means minus 1 by 2, c means minus 1 by 2, minus 1 by 2 minus 1 by 2 is minus 1. Substitute all these ABC values in equation 1. In equation 1, new frequency is equal to k L to the power of a means minus 1, m to the power of b means minus 1 by 2, and t to the power of c means 1 by 2. Therefore, substitute k, L minus 1 will go to denominator and becomes L plus 1, and then under root t to the power of half, that is t to the power of means under root t, and minus half, m will go to the denominator and will become plus, therefore m to the power of plus half, that therefore it all will come under root. So this is the final expression which we have derived. That is frequency of a stretched string. It depends upon length, mass per unit length, the tension T in the string. Therefore, nu is equal to K by L under root T by M. Under root T by M. So now this is our second derivation. This is our second derivation. So take let us take uh, the third example. Let's go for the third example now. Third application. Let's go for our third application. Sorry. Let's go for our third application. The third application, conversion of one system of units to another. Conversion of one system of units to another. So you can see what is one system of unit. As I told you, three systems of units we have studied in this chapter. That is MKS system, CGS system, and FPS system. Not only that, they may give you some other system also. Then converting one to another. That is our topic now. So it is based on the fact that the magnitude of a physical quantity remains the same whatever may be the system of units. Whatever may be the system of units. So magnitude will be always same. If U1 and U2 are the units of measurement of a physical quantity Q, and N1 and N2 are the corresponding numerical values, then Q is equal to N1 U1 is equal to N2 U2. It will be better if we explain with one example or two examples. So N1 U1 is that is the one system, N2 U2 is the other system. U1 U2 are the units of measurement, and then N1 N2 are the corresponding numerical values. So to understand this, we have to definitely see one example. We have to see one example. Now let M1, L1, T1 be the sizes of fundamental units of mass, length, time in one system. Let us take M1, L1, T1 are the sizes of the fundamental units of mass, length, and time in one system. Now we have to convert it into second system. So let M2, L2, T2. L2, M2, L2, T2 be the corresponding units in the second system. Then, if the dimensional formula of the quantity, whatever the quantity we are taking, let it be Q, let it be M to the power of A, L to the power of B, and T to the power of C. Therefore, U1 is equal to M1 to the power of A, L1 to the power of B, T1 to the power of C. That is the first system. Second system, U2 is equal to M to the power of A, L to the power of B, and T to the power of C. Now, as I told you in the previous one, N1 U1 is equal to N2 U2. U1 means M1 to the power of A, L1 to the power of B, T1 to the power of C. That is equal to N2 into U2 means M2 to the power of A, L2 to the power of B, and T2 to the power of C. Therefore, N2 is equal to N1 into M1 by M2 into A, L1 by L2 into B, T1 by T2 into C. It's better we will take one example and explain it. It's always good to see with example. Let us convert joule to erg. SI unit of energy in joule. SI unit of energy is joule. That is SI unit of energy is joule. CGS system, for the same energy, the unit is erg. Now we have to convert joule to erg. Dimensional formula for the energy M1 L2 T minus 2. M1 L2 T minus 2. Here the powers A is equal to 1, B is equal to 2, C is equal to minus 2. Clearly you can see here. Let us make a table. Left side SI system, right side CGS system we will take. So in SI system, mass is equal to 1 kg. We measure in kg. How much it is equivalent to CGS system? It is equivalent to 1000 grams. That means CGS mass is equal to 1 gram. In SI system, length is measured in 1 meter. That is equal to 100 centimeters, whereas in CGS system, it is 1 centimeter. So we converted meter into centimeters in SI system. Now, T1, 1 second, both the systems. T2, T1, both the systems, it is 1 second. N1, 1 joule, they have given in the problem. Into how many eggs? This we have to find now. Substitute all of them in the same one which we have discussed the previous formula. N2 is equal to N1 into M1 by M2 to the power of A, L1 by L2 to the power of B, T1 by T2 to the power of C. Substitute all the values which I have mentioned here. M1 is 1000, M2 is 1, L1 is 100, L2 is 1, T1 is 1, T2 is 1, and to the power, first one to the power of 1, second to the power of 2, third to the power of minus 2. Therefore, this is 10,000 means 10 to the power of 3, 100 square means 10 to the power of 4, and then 1. All together it is 10 to the power of 3 plus 4, which is 10 to the power of 7. Therefore, 1 joule is equal to 10 to the power of 7 eggs. Let's take another example. Let us take another example. So let us take the value of G, that is universal gravitational constant in SI units. When its value is given in CGS system, they have given the universal gravitational constant in CGS system. And then what we have to do? We have to convert it into SI system. We have to convert it into SI system. F is equal to, we know the formula, G m1 m2 by r square. Therefore, G is equal to, send r square to that side. Therefore, you will get G is equal to fr square by m1 m2. That is dimensional formula of G m1 l1 t minus 2 and then that is dimensional formula for G we are taking. First the one, that is m1 l1 t minus 2 is for the force, then it is multiplied by r square here. R square means length square L2 divided by m1 m2. Therefore m 2 m's we have kept. Once again I repeat, G is equal to fr square by m1 m2 for f m1 l1 t minus 2, for r l2, and for divided by m1 m2 m. Altogether it comes m minus 1, because m square will go up m minus 1, l 1 plus 2 3, and t minus 2. So let's write the powers. A to the power of minus 1, A is equal to minus 1, M to the power of minus 1, that is A is equal to minus 1, B is equal to 3, C is equal to minus 2. Let's write the table like the previous example. They gave in CGS units. We have to find in SI units. Therefore, N1 is equal to 6.67 into 10 to the power of minus 8 they have given. Let's write the value. We have to find N2, put a question mark. M1 in CGS system 1 gram, M2 it is a SI system 1 kg, that is equal to 1000 grams. L1 1 centimeter in CGS system, in SI system L2 is equal to 100 centimeters. T1 1 second, T2 1 second. Both the systems time is same. Substitute them in this formula. N2 is equal to N1 into N2 means which we have to find, n1 which they have given, n1 into m1 by m2 to the power of a, l1 by l2 to the power of b, t1 by t2 to the power of c. Therefore substitute the value of n1 6.67 into 10 to the power of minus 8, m1 value 1, m2 1000 to the power of a means minus 1, l1 1, and l2 is 100 to the power of b means 3. T1 is 1, T2 is 1 to the power of c. C means minus 2. Therefore, 6.67 into 10 to the power of minus 8. This 1000 to the power of minus 1 means 10 to the power of minus 3 whole to the power of minus 1. 100, that means 10 to the power of minus 2 whole to the power of 3, then 1. Then it will become 10 to the power of minus 3 whole to the power of minus 1, that's plus 3. 10 to the power of minus 2 whole to the power of 3, 10 to the power of minus 6 into 1. Therefore, once you add all the powers, it will become 6.67 into 10 to the power of minus 11. In SI system, Newton for force, meter square for length, and kg to the power of minus 2, that is for the mass, because we have seen here. So fr square by m1 m2, fr square by m1 m2, this is this one. Therefore we are substituting them, and we are getting n2 is like this. That means g in SI system is 6.67 into 10 to the power of minus 11 Newton meter square kg to the power of minus 2. I hope you understood this third application with this example. I hope you understood all the applications. It's very, very, very important for a 5 marks questions. Take care you solve as many as numericals possible. Then you will become very good expert in this particular applications. All the best. I hope you can use the applications and learn better to answer the questions very well. So I have also given one more example here, a third example. I hope you can go through it on your own, because it may take some more time. Here they have given a new system which has 220 centimeters, 250 grams, and half minute as fundamental units. Then let us find its equivalent of 100 joules. Joule is the unit of work in SI system. Write the dimensional formula of work, M1 L2 T minus 2. Here powers A is equal to 1, B is equal to 2, C is equal to minus 2. N1 is equal to 100 joules, which is given in the problem. N2 is question mark. Same model, you write this SI system one side, new system at the other side. Substitute them in the formula, the same formula like this, and then you can substitute them. Sorry. So substitute them in this particular formula and all the values. Once you substitute, you will get it is 9 into 10 to the power of 6 new units. Same model you proceed, you will get the answer. So you can go through, everything is neatly given, you can go through that. So in this way you can find uh, equivalent units in the new system. I hope you understood this particular topic, the applications of dimensional formulae. All the best. We will meet again in the next video. Thank you for watching this video. God bless you all.